Hey guys, welcome back to another video. This is going to be the last video for physical chemistry. I've already done questions 1 through 40 in other videos and I'll link those in the description. So yeah, let's start. Question 41. Ethanoic acid is mixed with ethanol. The ethanol is contaminated with a small amount of methanol. The following equilibria are established, where ethanoic acid reacts with ethanol, producing ethyl ethanoate and water. Okay, so that's the first equation, R1. And ethanoic acid reacts with methanol to form methyl ethanoate and water. That is reaction 2. So basically they're mixing ethanoic acid with a mixture of ethanol and methanol. So ethanol is contaminated with a little bit of methanol. As a result, there are 2 reactions. Okay, fair enough. So which statements about the equilibrium mixture is correct? Which statement about the equilibrium mixture is correct? Okay, so ethyl ethanoate will be formed because there is much more ethanol present than methanol. No, even if the percentage of ethanol is much more or much greater than methanol, it doesn't mean that methanol will stay unreacted. It's not going to stay unreacted in the presence of ethanoic acid, in the presence of another reactant. So it's going to react as well, giving a different product, which is methyl ethanoate. Okay, so A is not going to be the answer. B, in this mixture, this is the reaction constant 1 divided by reaction constant 2. So to find out the next that expression, let's find the reaction constant for reaction 1 and reaction 2. So for K1, the products on the numerator, H2O times 1 mole of CH3 is COO, CH2, CH3. Okay. And in the denominator, we have the reactants, which is ethanol and ethanoic acid. Okay, so ethanoic acid and ethanol. Okay. For K2, we have H2O times methyl ethanoate. Okay. And in the denominator, we have methanol and ethanoic acid. Since water and ethanoic acid are the common products and reactants respectively, I have cut them off or just simplified them. So I'm left with an expression where I have ethyl ethanoate, methanol, and ethanol and methyl ethanoate. So this is the expression I'm getting when I'm dividing K1 with K2. So is this what they have given as the option? No, they have given ethyl ethanoate divided by methyl ethanoate. So no, this is not going to be the answer. If they had given this, then it would have been correct. Okay, C. What does C say? Adding water to the mixture will alter the mole ratio of the 2 esters. Adding water to the mixture will alter the mole ratio of the esters. What are the esters? The esters are ethyl ethanoate, EE, and methyl ethanoate, ME. Okay, so they're saying, since this entire reaction is taking place in one container or reaction vessel, if they add more H2O, what happens? What would happen is Due to an increased mole of H2O, the reaction equilibrium shifts. Where? Left-hand side. Why? Because there are more products. The concentration of products have increased. If the concentration of products have increased, what happens is, for both cases, for reaction 1, the products will increase, which is H2O, and as a result, more reactants will be produced in both cases, in both reaction 1 and reaction 2. So what's going to happen? What's going to happen is more of these will be produced for both reaction 1 and reaction 2. If that's the case, will it affect the molar ratio between ethyl ethanoate and methyl ethanoate? Now logically, what's going to happen is, let's assume a number. Let's say you have not added any amount of water. You have not added any amount of water. So you have not added this. After this entire reaction, both the reactions have reached equilibrium. Let's say the amount of ethyl ethanoate is 4 mole. Let's just assume that. And the amount of methyl ethanoate is 2 mole. After both the reactions have reached equilibrium. They are now in equilibrium. So if they have reached equilibrium, I'm assuming the amount of ethyl ethanoate is 4 mole and the amount of methyl ethanoate is 2 mole. Now, what will happen if water is added? Now let's add the water. Let's add H2O. After adding H2O, 4 mole, let's say, will decrease to 2 mole. It has decreased to 2 mole, and 2 mole over here has decreased to 1 mole. Why? Because those extra 2 mole and over here 1 mole will be used in producing what? The reactants. In producing the reactants. What are the reactants? Ethanoic acid, methanol, and ethanoic acid, ethanol. The amount of these will increase. Now, after the equilibrium has shifted, on the left-hand side, we are left with 1 mole of methyl ethanoate and 2 moles of ethyl ethanoate. So, is the ratio between both EE and ME the same? We had 2:4, which is 1:2, and then we have 1:2. So the ratio has not actually changed. Now I've just made up these numbers to explain. These are not exactly the moles, but what I'm trying to say is, even if you increase the amount of water, the ratio that was initially present between ethyl ethanoate and methyl ethanoate stays the same, stays constant. The amount in which they decrease, the products decrease, which is ethyl ethanoate and methyl ethanoate, will still follow the same ratio. So even after the amounts have decreased, the ratio between ethyl ethanoate and methyl ethanoate will not change. It will not increase, it will not decrease. The ratio of the products will be same, even though the amounts have decreased. The total amounts have decreased. So C is not correct because the ratio will not change. The amounts, the amount of each of the esters will decrease, but the entire ratio will not be changed. D. Adding methyl ethanoate to the mixture will increase the number of moles of ethyl ethanoate. So, let's say you have added what? Methyl ethanoate. So if you add methyl ethanoate, what's going to happen? Again, the equilibrium will shift to the left-hand side. If the equilibrium shifts to the left-hand side, what happens is more reactants will be produced. So what are the reactants? Ethanoic acid and methanol. More ethanoic acid and methanol will be present. Now this ethanoic acid, since the reaction is taking place in the same vessel, this ethanoic acid is also available for reaction 1. This ethanoic acid, this excess ethanoic acid, or the more moles of ethanoic acid is also available for reaction 1. If that's the case, we can say the amount of ethanoic acid for reaction 1 has also increased. So seeing that the reactants for reaction 1 has increased, we can say the reaction equilibrium for reaction 1 should shift to the right hand side. Why? Because the reactants have increased, especially ethanoic acid. If that's the case, more moles of ethyl ethanoate should be produced. Why? Since the equilibrium has shifted to the right hand side. So they have mentioned adding methyl ethanoate to the mixture will increase the number of moles of ethyl ethanoate. So yes, this is correct. If you add more methyl ethanoate, more reactants will be produced, which is ethanoic acid. If more ethanoic acid is present, it will react in reaction 1 as well as reaction 2. But for reaction 1, more ethyl ethanoate will be produced as well, since the amount of ethanoic acid has increased. If there are more ethanoic acid present, it can react and give you ethyl ethanoate. So this conclusion that more ethyl ethanoate will be present is correct. So this is the right answer. So 41 is D. Okay. 42. A reaction pathway diagram for the reaction of aqueous sodium hydroxide and dilute sulfuric acid is shown. So NaOH and H2SO4 reacts, giving you sodium sulfate and 2 moles of water molecule. What is the value of enthalpy change of neutralization? So they have asked you the enthalpy change of neutralization, not the net enthalpy change. If they had asked you what is the net enthalpy change, it would have been what? It would have been X. However, they've specifically asked you for the enthalpy change for neutralization only. Since they have done that, that means it's not going to be the net enthalpy change. Why? Because if you look at the products, 2 moles of water molecules have been produced. So this is not exactly the enthalpy change of neutralization, because more than 1 mole of H2O has been produced. So if your answer was A, X, it would have been wrong. Now, the thing is, all of these are aqueous. Why? They are soluble in water. These are NaOH is a strong base and H2SO4 is a strong acid. So, since they're soluble, they're already aqueous, and they are already as ions in the reaction vessel or in the solution. After the reaction has taken place, sodium sulfate is already in aqueous form. No new bonds have been specifically been formed yet. Why? Because Na is an ion, sulfate is an ion as well. So this enthalpy change, where is it going to be coming from? The ionic equation, the ionic reaction, which is between H plus OH giving you H2O. In this case, they have given you 2H2O. So this is the enthalpy change. From this reaction only, you will get the enthalpy change, or X. But you don't want X. What do you want? You want just the enthalpy change of neutralization, which is for 1 mole of water, So it's going to be x divided by 2. Why? Because enthalpy change of neutralization is just asking you to give you the amount of energy change when 1 mole of H2O is formed, or when 1 mole of the product has been formed in a neutralization reaction. In this neutralization reaction, 2 moles of water has been formed. And we are not taking into account NaOH, H2SO4 or sodium sulfate. Why? Because they are already soluble in water. They are already aqueous. Now, the other important thing is, for all neutralization reaction where a strong base and a strong acid is reacting, over there, the neutralization, the enthalpy change of neutralization is same. It's around 57 or 53 kilojoule per mole. Why? Because for when a strong acid and a strong base reacts, they are already soluble, which is why the main enthalpy change comes from the water molecule being formed. So it's by the way, it's negative 57 or 53, something like that, kilojoule per mole. And this is the same for all cases where a strong base and a strong acid reacts. It's the same for all strong base and strong acid reacting with each other. So if you take any other example other than NaOH and H2SO4, the enthalpy change of neutralization would be still the same. So I'm given a table over here. These are strong acids, and these are all strong bases. So if these react, the enthalpy change, the enthalpy change of neutralization are going to be the same, regardless of which one you're reacting. If they are strong acid or strong bases, the enthalpy change of neutralization will be the same, regardless of the reactant within these. Why? Because they're soluble and they're very reactive. Which is why the main enthalpy change is actually coming from the bond forming for the water molecule only. Other than this, there will be cases where a strong base can react with a weak acid, or the other way around. In those cases, it's different because they do not easily ionize, or they don't fully ionize. They partially dissociate or ionize, which is why in those reactions, the enthalpy change of neutralization is not constant. There is a factor of how easily the H plus ions are lost or gained, which is why the enthalpy changes are slightly or moderately different from one reaction to another. But in cases of a strong acid and a strong base reacting, since both of them can ionize entirely or fully and can dissociate fully, the enthalpy change of neutralization stays the same. So for this reaction as well, the enthalpy change of neutralization is going to be x divided by 2, which is the enthalpy change of 2 molecules of H2O being produced divided by 2. So you're just finding out how much energy it takes to form 1 mole of water molecule. So see, x by 2. I've given you a bit of extra information over here for strong acid and strong bases, but it's sort of important to know where you may have to take into account Is it a strong acid? Is it a strong base? Is it a weak acid? Is it a weak base? Because the enthalpy changes can vary accordingly. So you would know from now on that if it's a strong base and strong acid, the enthalpy change of neutralization is not going to be different. There are questions. There was one question I've done in the previous video where there was a question where two equations were given and you had to figure out what the enthalpy change of the other equation was going to be based on the previous equation. So you had to know that the enthalpy change of neutralization for both of those would be the same. Why? Because both of those were strong acid and strong bases. So that is why this bit of information is, I believe, quite important to know. Yeah, that's it. 442. 43. Question 7. Black powder is a mixture of potassium nitrate, carbon, and sulfur. The mixture reacts as shown. All of these react to form these gases and these solids. A sealed tube containing black powder has a volume of only 10 cm3. When all of the black powder reacts, the reaction causes the pressure of 2 into 10 to the power 6 pascals and a temperature of 2500 Kelvin. Okay. The volume of K2CO3 and K2S produced can be ignored because they are solid, and it's not because they're solid, but they're going to occupy significantly less volume, I guess. So the volume of them can be ignored. Okay. How many moles of potassium nitrate are contained in the sealed tube? So they've asked you to ignore the moles or how much these have been produced. We're going to do that. In that case, they've given you some important information. They have given you the pressure, the temperature, and the volume. And from this, you can already guess what you need to do. You need to use PV is equals to nRT. If you do that, PV is equals to nRT. Why do you want that? You want to find out the total moles of all of these gases. The sum of the moles of all of these gases. You know the pressure, 2 into 10 to the power 6. You know the volume, just 10 cm3. You convert that to meters cube. How do you do that? Divide by a million. And you find out the moles. You know the reaction constant, 8.31. The temperature is 2500. You don't need to change anything. And after you do that, you would know the moles are this. The moles of the gas produced. The total moles. So, 3 moles of CO2, 3 moles of carbon monoxide, 2 moles of nitrogen. The sum of these will give you 9.63 into 10 to the power of minus 4 moles. Since they're gases, you can do that. So, from this, you can use molar ratio. How many moles of gases are there? 3 plus 3 plus 2. 3 plus 3 plus 2, which is 8. There were 4 moles of potassium nitrate, 4 moles, and now 8 moles of gas. 4 is to 8 is 1 is to 2. And you know the mole of the gases, which is 9.63 into 10 to the power of minus 4. You divide it by 2 to get the moles of potassium nitrate. So yeah, A is the answer. Question 15. The Boltzmann distribution for 1 mole of a gas at temperature T is shown. Number of particles with energy E. This is the normal curve. This is the normal curve, initial curve. 1 mole of the same gas is added. This is 1 mole, and more 1 mole was added of the same gas, and the gas remains at temperature T, which dotted curve shows the distribution with added gas. So basically, the answer is A. Why? First of all, they have given you 2 bits of information. They have doubled the amount of particles. 2 times number of particles. So if they have done that, the amount of particles inside the container, where is it? Okay, inside whatever it is, let's say inside this box, the amount of particles have doubled. They've also given you another important information. The temperature is same temperature. What does that mean? It means that more energy has been given. Why? Initially, there was only 1 mole of gas. 1 mole of gas. And for 1 mole of gas to have 25 degrees Celsius as the temperature is going to be easy. Or let's say it's going to be normal. But when you add 1 more mole of gas, it won't have 25 degrees Celsius as the temperature. It will decrease. Why? Because that energy will be distributed between more gas, double the amount of gas. So the temperature will decrease. However, they've mentioned the temperature stays constant. So let's say the temperature will stay at 25 degrees Celsius. What do you do then? You have to add more heat. You have to give more energy. Okay. For which the temperature stays constant. So we have deduced the number of particles have increased and the temperature stays constant. Which is why the number of particles have increased substantially. So you could also argue for C, but the problem is they have mentioned temperature stays same, which is why the overall shape of the curve, or let's say the place where the peak would be, should be same. Because Boltzmann curve, at least for your papers, the shape of the curve is only affected by, or usually affected by, only temperature. Only temperature can affect the shape of the peak or the shape of the curve overall. The other factor is catalyst, but it does not affect the shape or change the shape of the curve. It only changes the activation energy. The activation energy, where more particles have enough energy. So the shape is usually only changed by temperature. If that's the case, you cannot go for C. And you can't go for D or B because the amount of particles have increased and these don't show that. So since the particles have increased and temperature is constant, the shape of the curve should be constant, but the amount of particles should increase. The amount of particles should increase, which is why A is the correct option. Okay. 45. Question 40. Which statement about atoms and molecules is correct? The molecular formula of a compound is the simplest whole number ratio of atoms of each element in the compound. No, that is empirical formula, so not A. 1 mole of any substance contains 6 into 10 to the power 23 atoms. So let's say if it's CH4 methane, it will have 5 times the Avogadro's constant. Why? Because there are 1 and 3, 4, 5 atoms in it. So the number of atoms would be 5 times the Avogadro's constant. However, if they said molecules, then in this case, in methyle's case, it could be that 1 mole of CH4 contains 6 into 10 to the power of 23 molecules, not atoms, molecules of CH4. So yeah, this is wrong because it's not specifically, it's not always atoms, it's not always molecules either. So they could have phrased this as 1 mole of any substance contains 6 into 10 to the power 23 number or amount of that substance, because you don't know if it's atom or a molecule. So yeah, if it was phrased a bit differently, it could have been correct. So C, the relative atomic mass of an element is the ratio of an average mass of one atom of element to the mass of an atom of carbon-12. It's not compared to the mass of a carbon atom, it's compared to 1/12 of the mass of a carbon-12. Because for carbon, the mass is 12. Okay, so if for carbon the mass is 12, it's compared by 1/12. 1/12. So it shouldn't be 1/12. Okay. B. So C is wrong. The relative formula mass of a compound is the sum of the individual atomic masses of all the atoms in the formula. Formula mass is usually used for ionic compounds. So yes, this is true. Individual atomic masses will add to the formula mass. Okay, D is correct. Diethyl zinc C2H5 2Zn zinc. Diethyl zinc is added to sodium hydroxide. 2 reactions occur. Reaction 1, reaction 2. So for reaction 1, what's happening is H2 is giving H plus ion. H2 is giving H plus ion. And this C2H6 is it's coming from C2H5, where it's gaining this H plus ion from H2O. So H2O is acting as an acid. Reaction 2, H2O loses H plus to form OH ions. So this is giving off H plus ion, acting as an acid again, and forming OH for zinc hydroxide. Which is why in both cases H2O is acting as a Bronsted-Lowry acid. So 46B. Okay, 47. Hydrogen and iodine react to form hydrogen iodide in an exothermic reaction. The equation is shown. H2 reacts with I2, giving 2 moles of hydrogen iodide. A 1 meter cube reaction vessel contains hydrogen iodide gases at equilibrium. The temperature is changed such that the total pressure in 1 meter cube vessel doubles. Okay, what is the effect of the value on the value of Kp and on the position of the equilibrium? They have said that the temperature is changed to double the pressure. Volume has not changed. So if they've changed the temperature to increase pressure, what could they do? They could increase the temperature. So temperature is increased. You know, forward reaction is exothermic. They've mentioned it. If forward is exo and the temperature is increased, the backward is favored. The backward reaction is favored. Why? Because the backward reaction is endothermic. So more reactants will be produced. Total pressure will increase, but it does not affect. Why? Because there are 2 moles of gas on this side and 2 moles of gas on the right hand side as well. So the pressure will have no effect. So the backward reaction is helped and more reactants will be produced. So effect on the position of the equilibrium moves to the left. As mentioned, the backward reaction is helped. And effect on the value of pressure constant. The pressure constant. Okay. So if we write the pressure constant, the product HI square and the reactants hydrogen and iodine. Okay. Hydrogen and iodine. If the reactants increase, the moles of reactants increase, that means the moles of products have decreased. So, if the numerator decreases and denominator increases, the entire Kp value will decrease. The entire Kp value will decrease. Since the numerator decreases and the denominator increases. So, let's say it was 2 by 5. Now it is 1 by 6. So, 1 by 6 is obviously smaller than 2 by 5. Which is why A is the answer. Last question for this series. Question 48. 2 half equations are shown. Oh, redox reaction. Manganese reacts with water, gains 3 electrons, to form manganese oxide and 4 OH ions. So this is what is this? Reduction. This is reduction. And sulfide is gaining or losing electrons, going from +4 to +6. So it's losing 2 electrons. So this is oxidation. So it's losing 2 electrons. And in the previous half equation, it's gaining 3 electrons. The number of electrons are not balanced. What can we do to balance the electrons? We can multiply the above equation with 2 and the equation below with 3. If we do that, we will be left with 6 electrons above and times 3, 6 electrons below. So the entire equation is balanced. What will we be left with? We'll be left with 2MnO4 plus 4H2O plus 6E. I'll write it down. So plus 6OH plus 3SO3 2 minus, giving you 2MnO2 plus 8OH plus 3 sulfate plus 3H2O plus 6 electrons. You can cancel the number of electrons. electrons. So you can simplify the number of water molecules. There are 3 on this side, 4 on this side. So let's go to 4 because 1 will be left. And what else can you simplify? OH. There are 6 on this side. Let's write it as 2 OH. So you're left with 2MnO4, 1 H2O, 3 SO32 minus 2 MnO2 plus 2 OH plus 3 SO42 minus. So which is U? This is U. And V is this. And W is this. And X is this. And which one is Y? This is Y. This is Y. And this is Z. Great. So U is equals to X is equals to Z. U, X, Z. All of these are 2. So, yep. 1 is correct. Manganese is reduced from +4 to, from +7 to +4. So yes, it is reduced. Sulfur is oxidized from +4 to +6, +4 to +6. Yes, it is oxidized. So that is it. That's the last question from physical chemistry. I hope I could solve enough questions. And yeah, that's it. I'll next start off with inorganic chemistry and make more videos from A2 level as well. So